Hey everyone, welcome back to lesson 24. We're going to kind of do the reverse of a video we did previously. I don't remember the lesson number, but students, I've been doing videos where the students would get a random equation and they would have to graph it by clicking and dragging 2 points. We're going to do the reverse. A random graph is going to be given and they have to type the equation. So let's get started here. I'm going to show you what this looks like, first of all. Preview. Okay, so here we have a random line. Again, if I were to close this and open it up again, I get a different one. So every time the students open this activity, they get new random equations. Likewise, all of their classmates will have different equations. So just be aware of that if you do give this and be like, hey, everybody, look at number 1, realize that everybody has a different one. And then when they type in their answer, so let's see, our slope here is 3/2 and then -7. Okay, so the student gets the feedback, the teacher gets the feedback, and I do have, well, here's another one. And I have added the one with the line so they can practice forever. And if they do happen to get a horizontal line, it will accept it if you put in just the number or even if you put in 0x plus. So the students, both are correct. Okay, so we are just going to add a new slide and pretend we're starting this from scratch. Again, I will give you a link to this very activity. That way, if you're not really comfortable with the coding and you just want to grab the activity and just copy a slide out of it, help yourself. Okay, so for this, we're going to need a graph component. We will also need a note component to tell them if they're right or wrong. For those of you doing that, if this is a quiz or something, maybe you don't want that. A note component to give them some directions, and I need math input for them to type their answer. Okay. Oh, let's see here. I'm going to start with the graph component, and I'm going to label this graph 4 because I am on screen 4. Then I'm going to edit the graph. So edit the graph and editing the computation layer for the graph are 2 separate things. So this is computation layer here. Clicking on the grid will edit the graph. Now, I want to have 2 points just kind of randomly generate in my graph here. So the first one I want is the y-intercept. So I'm going to call that 0z. And we'll get to that later. I don't want the students to see it. So I'm just going to click on this little dot right here, and now it's invisible. My other ordered pair, I'm going to call that AB. AB. There we go. And I'm going to press return so I get those sliders. Not a big deal there. I do want it to calculate the slope. So M will equal, and again, y2 minus y1. So this is B minus Z over A minus 0. So over A. Okay. And I do want them to see the line. I just don't want them to see points on the line. And, those of you who teach this, recognize that there is a difference, that students do have some trouble finding points on a line. So that reminds me, I gotta turn this one off. I don't want them to see that one either. Okay, so y equals mx plus z. That will give us our slope and our y-intercept. Okay, that's all we're gonna do here in the edit graph part. So we're gonna click done. And now I'm gonna go into the computation layer of the graph component. Now, I want this to be read only because it will try to tell me if it's right or wrong, and this is just, it is what it is. The students aren't doing anything in the graph part. All right, I do need random numbers happening, so R equals random generator, and I'm going to leave the parentheses blank for now. We know that we use that if we're going to add the button for infinite practice. Okay, so now here's where I'm going to have it randomly generate the numbers that we just typed into the edit graph part. So the number z, right, that was our y-intercept. I want that to be a random integer from -9 to 9. I'm fine with it being 0. Any integer from -9 to 9 is fine with me. The number b, Same thing. I'm fine with anything from -9 to 9. You could even go 10. I'm just afraid that if it's on the edge of the screen, the students may not see it quite right. Maybe they do, whatever. That's enough of a variety. Now my last number here, right, in those ordered pairs, my last variable is A. I do not want A to end up on the y-axis because I already have a point there, and I don't want to deal with like x equals. So A can be any number from -9 to +9, just not 0. So I'm going to go with A sign. And A is either going to be positive or negative. So I have two options here. It's going to be a random integer, 1 to 2. So two options. Either it's positive or it's negative, right? So the number A in this particular graph will be, let me just start a new line here, when A sign equals 1, I want it to be a random integer from 1 to 9. Otherwise, A sign equals 2 and it's going to be negative, so that will be a random integer from -9 to -1. Okay? All right, so I have my numbers A, B, and Z. Okay, and that's it. I think if we preview this, we're going to see a random line show up. There it is. And if I go back in, it'll be a different one. Yep. So we did that okay. All right, the math input component. I'm going to label this Math 4. All right, I'm going into the computation layer here. Now this first part is optional. I want it to automatically show up as y equals. Like I'm going to type that part of the equation for the students. Just because mine seemed to forget. So I'm going to use these. It is the button that is to the left of 1. And I'm doing that because that is the math font. So then y equals will look all mathy instead of texty. Okay, that part is optional. Now what I want to do is I'm going to grab the slope and the y-intercept information from the graph component. And then I'm going to do the same thing. I'm going to grab the slope and the y-intercept information from this component, which is the student input, and then I'm going to see if they match. So those are the three things we're going to do here. So get slope and y-intercept from graph. So the graph slope equals, this was called graph 4 dot number, and we called that m, right? Remember we put that in there? Then the graph y-intercept, we're going to get that from graph 4, the number z. Okay. Now I want to get the slope and y-intercept from student input. So this very component. Let me flip my notes here. Okay, so this part I can do it, but I really don't understand it. And again, I want to point out that I don't know what I'm doing here. I'm making these videos based on what I'm learning on my own and what I'm finding in the forum and just playing around, and I'm just sharing that with you. I'm not an expert. I'm not affiliated with Desmos at all. This is me just learning and showing you, and I'm hoping that some of you are finding this useful. But my whole point is you don't have to be an expert to share. Where am I here? I'm going to call this line equals x, y, and look at that pops up, so that's a thing. I don't even know what a sink or a source is, and here I am like with 100 and some followers. That's kind of scary because I feel some kind of responsibility that I should be competent in this, and I'm not. Where was I? Okay, so we called this math 4 dot latex. I thought latex had to do with condoms. I don't know what latex is. Sorry. All right, so when you use this XY line thing, I figured out that it somehow recognizes what the slope and the y-intercept is, and it does things. How's that? All right, now from this, I'm going to call the student slope, so S slope will equal, and I called this line dot slope, and it knows that. So there must be something in that XY line stuff that does that. Then next line, what's going on? The student y-intercept, I'll call that SY-intercept, is equal to line dot y-intercept. So now that's pulling that slope and the y-intercept that the students input it. Now, I want to check to make sure that the slope in the graph matches the slope the students are giving, and the y-intercept in the graph is matching the y-intercept that the students are giving. So check that slopes and y-intercepts match. Okay, so check will equal if graph slope equals student slope and graph y-intercept equals student y-intercept. Okay, then that means they're correct. Now, because this is where the students are putting their information, this is where I can use the correct command. And if you look, that's a sync. I didn't know that. Check is a variable. I do like that shows up. Fine. Okay, so now what we have so far, if we go in and preview this, I have no directions, but I know what to do. This is what, 1/2 x plus 3. And now the teacher will know if the student is correct. So if you wanted to stop at this point, at least you have something, right? I do want to give them some directions. Let's put that here. Type the equation of the graphed line in slope-intercept form. Okay, so now the directions are appearing and the students know what to do. All right, I am going to give the students feedback on whether they are correct or not. So I'm going to go into this top note component. And I'm still going to call it check, but we have to pull it from the other component. What was that? Math4 dot script check. Okay, so I don't have to rewrite all of that. That would be miserable. I want it to display when check happens, so that means when they're right, I want this. Otherwise, that means they're wrong, and I want this. Control Command Spacebar gives me my emoji menu. That's what I like to use, if it lets me. Let's try this one. What's going on? There we go. Okay, so the content of this note will be correct, and then the weird notation, I want that display to show up. And don't forget to close your quotation marks. Okay, now the students will know if they're right. So this pretty much has everything I want. So y equals negative 3x plus 1. No, that's not right. We're down here. This would be negative 5/2, huh? I love that feedback. That's not right. 6. No, negative. I don't know. What's going on here? Did I mess up? There's another point on here. Right there? 7/2? I can't count. There we go. But I see that feedback was very helpful for me. All right, what I like to do is copy and paste this. So I'm going to do a Command C. When you click up here, Command C, Command V. Now click on the next one. Command V. Do that as many times as you want students to practice. Then add an extra one. And what we're going to do here is, again, for some of my students, they just love to practice, practice, practice. Not a lot. Okay, so 1, and it's me. And we're going to add infinite practice here for those students who are like us. So I'm going to add a button. The placement of that is fine. I'm going to call it button 7 because this is screen 7. I am going to go to, well, I'm going to call this get a new line. Period. All right, wherever we put the random generator stuff, which was here in the graph computation layer. So we're going to go there. And here where it says R equals random generator, we're going to type the name of the button. It was button 7. Dot press count. And that should do it. If I check here, get a new line. Every time I do that, it generates a new line for me to try out. And then students can practice forever and ever and ever. Amen. Okay, guys, there you go. I hope you enjoyed that, and I'll continue to keep learning and sharing, and maybe one day we'll all be experts. See ya.